So to continue on the radical expressions, you might be wondering, why do we need to learn about exponents and all those rules before we come into radical expressions? Well, this is where it all connects together. Here we have, let's say, 4 squared. We know that's going to equal 16. Well, how do we go back to just the 4 if it's squared over here? Meaning I want my answer to just be 4. Well, we have to take the square root of 16. This right here is the radical. Ba-ba. And the number inside is called the radicand. And I know you can do this because I'm not going to accept any radicands. Now with, that's a cheesy joke, I'll cut it out. With this, it is assumed that it's going to be a positive number. For example, if you take -5 and you square it, you will get 25. If you take 5 and square it, you're going to get 25. However, if we take the square root of 25, because there's no symbol in front of here, we are assuming that the answer is going to be a positive. It's going to be the non-negative version of this. Now, if we had plus or minus square root of 25, the answer could be -5, or it could be +5. To talk about whenever we're doing radicals is the order it happens in. So let's say we have a square root of 144 plus the square root of 25. What is that going to get us? What do you think it's going to get us? Well, if we're assuming this is the square root, this is going to be 12. And remember, since there's no symbol here, we're assuming it's going to be the positive. Plus, that's going to be 5. It's going to be 17. Well, will we get the same answer if we do 144 plus 25, all of it square rooted? And what do you think? Well, what's going to happen is you have to finish this equation, part of this equation first. This counts as a form of parentheses. So when we follow PEMDAS, we have to do this first. So 144 plus 25, that's going to be the square root of 169. And that is this, when you take that, you get 13. So 2 different answers, even though we use the exact same numbers, all because of the order. What happens if we're going to have variables in this as well? Let's say we have 3 plus 12 square root of x minus 6 square root of x plus 17. And we want to simplify this expression. Well, just like in anything else we do, we're going to combine like terms. So what do you think is it going to be? Well, let's start off with the constants first. Constants. I don't want that. So we're going to add the 17 and 3, and we'll put those back here. Plus, that's a positive 20 because we're going to be adding it. Now, we're going to take these 2 right here, and we're going to assume that this square root of x is just going to be like another term. So I'm just going to go ahead and write that here as another term, not needing to simplify it, not needing to solve for it. And we're going to do 12 minus 6, since those are the coefficients. And we have 6 square root of x plus 20.